Yeah, started. Go ahead.
Yeah. So let me share the screen then. Yeah. So our first question is like palindrome pairs. We are given the list of unique words and we have to return the pairs of distinct indices I and j in the given list. So that concatenation of these two words is a palindrome. Like zero, I mean zeroth index one word is ABCD, then one is DCBA. So if you concatenate, they are a palindrome. This then one and zero. So this is one. Okay, and this you append again DBCA. This will this will be the what is it concatenated string. Then again for 3 to 2 you'll have this, and 2 to 4 you'll have this. So all these are palindromes.
So you can
You
have
have
two
to find.
pairs, yeah, and
Yeah.
0 1 1 0, right? You can have both ways. Interesting.
Yeah, you can append to the front, uh,
Back.
to the end, yeah, the back of the string. Yeah.
Mhm.
Yeah. Any constraints? Okay, let's see. Same. I mean, this example is also like that only. 0 to 1 and then 1, 1 and 0. I mean, prepending and appending. And
Yeah,
here, since 1 is empty, so it will always be single character. Yeah.
yeah. So there is one case like example three where one of the string is empty.
Yeah.
Second
Other,
is like the the one what you said about opposite ones, right? The bat and
yeah.
tab. Uh-huh. And the other is like if you look at the third example of example one, you have that LLS and SSL, right? That
Triple S. Yeah.
yeah. So they are not equal strings, but they still can form a palindrome.
Yeah.
So that is another case.
Yes. Yes. Overall, it forms a palindrome. I mean, yeah.
Yeah, but it's the way we always visualize a palindrome. Looking at the example, the first zeroth and first index, it's like just yeah, happen to each other or prepend to each other. Then they work, but I because they are different ones, right? And then if you mirror image both of them, they are same. Either of one, if you reverse it, it will be same. But
Yeah.
that's not the case with the LLS and SSSL, right? Yeah.
Yeah. Although they are different, but on combining their forms.
Yeah.
And we look at the constraint,
Yeah.
was
Sure.
5,000 something. the length, the length of each word is 300. Okay.
Mhm.
Then 5,000. This n can be 5,000. Okay. Oh.
So
Even
actually, just looking at how to make a palindrome or
yeah.
if string is palindrome, that's not a big of a deal, right? Here in this case,
Yeah.
yeah.
So look at the example 3. If we have another empty space,
Mm-hmm.
so what would that be? Are we, if, for example, if we have another empty space, so normally would that the answer be 4 or 6? Because we have two empty space string. Would that make a pair palindrome too?
I think so.
Empty string. I didn't get what you're saying.
Or if we have another empty string, append to the input in example 3. So we have two empty string. Would the answer be 6?
Yeah. Three.
Six
It should.
pair?
It
Well,
should.
actually, it might be
No.
Might
No.
invalid,
have been more.
right?
Actually, unique are only allowed. List will have unique words. So two, I don't think so. Two spaces you can have in a word is list.
Oh, okay. So we have only one single
One space. Yeah.
Yeah.
empty string. Okay, got it.
So it's like an invalid input. Just I just coded and I'm looking at it, but yeah, it
Oh.
doesn't accept. At least the lead code doesn't accept. That's good, but that
Yeah.
is a good thing to get clarified. Yeah, because then it will be infinite, right? If we have few of them uh,
Mm.
and one word. Okay.
many times.
Yeah. So that was a good observation. I also never thought of it. That's nice. Yeah. So, how do we go about it now? What
So
will be the
the
brute force?
yeah,
Yeah.
would that the brute force will like be we generate a, every pair I and j out of that array, and then probably inform the word like I plus j and another word in j plus I, and we check the palindrome.
Hmm.
Mm. Both the ways you are checking, prepending and appending.
Yeah,
Okay. So
If
you are suggesting that solution will be n square
yeah,
and into the size of the strings, right? Yeah. Mhm.
yeah, and then after n square we have to check the size that we check for the palindrome too, right?
Yeah.
O of n, NQ overall.
The
It
size will be
depends on
different,
the
right? Yeah.
length. Yeah,
Yeah. Because the length here of each and every word is only 300.
yeah.
But if you see the length of the input is 5,000. Yeah. So that is used. So 5,000 into 5,000 into 300, something like that. Yeah. Hmm. Okay. So that is a good one, I think. And that might even get accepted. I don't know. I didn't try that. Yeah. Hmm.
Yeah, it can be accept n square is accepted.
Right. Yeah.
It more than n square, right? Because we have to
NQ
compare, yeah, the length n square time the length of the word.
Yeah. But that's not big, right? It's only 300.
300. Yeah.
Yeah. So that should be fine, I think. Yeah.
Mm.
Yeah. Okay. If that's a brute force, then what will be a better way? A slight optimization or a good optimization?
One is like you can use a hash map, right? I mean,
Okay.
in in you take every word of the list and
Mm-hmm.
reverse the word and put it in the hash map or hash set, something like
Mm-hmm.
that.
Mm-hmm.
Better
Okay.
would be hash set. Yeah. Now, whenever you pick this word,
Mm-hmm.
let's try write an example only. That will be better, right?
Oh, sure.
Yeah. Annotate it. So here are the string will be what? So reverse of this, what do you say? DCBA,
Mm-hmm.
and reverse of this will be ABCD,
Mm-hmm.
and SLL. S will be S only, and this will be LL, S, S, S.
Okay.
Now you take every word from your list, right? And you check whether this word is present in your set or not. I mean, has set or not. So this is since it is present, right? And this, this is a reverse of your word. I mean, you are storing the reverse of this word, right?
Correct.
So when
Uh-huh.
you will pop it out from the set,
Mm-hmm.
you will get, you will back reverse you will do. I mean, DCBA, right?
Mm-hmm.
And that if you append it with this string, it will form a palindrome.
Okay, but so when you find that word, so why do you have to back reverse? Will
Okay,
that
I mean,
itself not be a palindrome?
it will be palindrome. I'm saying if somebody is asking you what will be, I mean, if I have to return this word, then it is a
Oh,
palindrome. You don't need to back reverse. But in case if somebody asks us to what that palindrome will be formed, then
yeah, makes sense. Yeah.
yeah. And again, like DCBA is there, so we'll check your DCBA is present in my hash set. And this DCBA came because of what? This one, right? Because I reversed this word and it came. That means if you take this word and this and forward of this word, both of them, if you club, they will form a palindrome, right?
Okay. Yeah. That's good. Okay.
Now, LLS is there, right? So we'll check whether LLS is present. Here it's not present, right? I'll say that's a special other case. I mean, I'll tell you for that. Now
Okay.
your S is present. Uh, I mean, if it is a palindrome in itself, then you don't need to push it into that. Like even, I mean, if you pop it out, it's a palindrome in itself, right? Simply yes.
Yeah.
What do
Single
you
word.
mean by that?
Or
S
we, or,
standalone.
we won't put those word into our what you say, this which is already a palindrome, something like that. Maybe we can put it in some
Okay, but you have
standard
to
in some.
append it with another word, right? Because you have
Yeah.
s alone is not enough.
No, okay. I'll tell you for that. So this is one case, right? I mean, the one this which I did. I'll tell you the other case. Yeah,
Okay.
this one I'm telling you, LLS. Okay.
Uh-huh.
So you first see, okay, in my string, this is there, L, L, S, 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 and apart from that, these two reverse words are there, which I'm not writing. I mean, think that it's
Okay.
there in the hash. Now you first check S. S is palindrome, right? I'm going this way, suffix way. So S is a palindrome. So then you check whether LL is present in my this, what do you say, set. LL is not present, because had LL been present, I would have taken from here and placed at this point, and it would have been a palindrome, right?
No,
So it's not present. So
no, no.
let's
That cannot be a palindrome, right? If you have LL and if you take S and then if you put LL beside S, it won't be a palindrome. You will have
why
to have S and
this.
LLL. Oh, okay.
Uh,
You're saying you put both sides?
yeah, but no, one side is already LLS, right? This is your palindrome, right? I'm starting from this side. Alone, if you take single S is a palindrome, right?
Ah, okay, okay, okay. You're taking one single. Okay, I got your point. Mm-hmm.
And so whenever you get a single string as a palindrome, then
So,
what you do, you check the rest of your string, okay?
mm,
Whether the reverse of rest of your string is present in the hash set, but it is not present, right?
mm,
So definitely this is not. Then you combine S1. This is not a palindrome. Then you combine this. This is also not a
mm,
palindrome, right? So
mm,
this you did from the right side. Now you do it from the left side. I mean, this was
mm.
my suffix way, right?
Right, right, right.
Yeah. Now if you go for the prefix way,
Mm-hmm.
let's go prefix LLS and S is there. S S S LL, right?
Mm-hmm.
So this L in itself is a palindrome, right? So I'll check whether uh, ls reverse of this is present in my word. It's not
Mm,
present. So I'll take now ll. Ll is also palindrome. So I'll check whether reverse of s is present here, and which
mm-hmm.
is true. It's present, right? So if I put here s, then it will become a palindrome.
Yeah, yeah.
Yeah. And same way, now let's take this string s, 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 l, l. So I'll check again suffix and prefix way. So I'll start from here. Single s I'll take. It's a palindrome. So I'll check whether reverse of this is present. It's not present, right?
Mm,
LLSS is not present in my hazard, then I'll take
right.
2. Since this is also palindrome, I'll check whether SLL is present and this is present, right?
Mm,
This. So SLL is present, so I'll put here SLL. Here. No, I mean this is the reverse of it, so you'll forward it and put, so it will be LLS. So 1
yeah,
and 1 is
yeah.
my, I mean LNL is my this, 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 and already is a value.
Correct.
So three
Yeah.
cases overall, if we summarize, yeah.
Mm.
If
Hello, Shashank? Hello. Oh, he is out.
I got lost, yeah.
Oh, yeah, no problem. Yeah, go ahead. Yeah, we are waiting for you. Yeah, go.
So overall, three cases we have if we summarize it. One is
Correct.
like
Mm-hmm.
if if you find a word whose direct inverse is present in your hash set, then that's a palindrome.
Mm-hmm.
Other is like this case where you go the, I mean, this is not, I mean, reverse of this entire word is not present in your dictionary hash set, right? So you try suffix way, you take each character. And since you find this is a palindrome, then only you check the rest part of it,
Mm-hmm.
whether the reverse of it is present or not.
Yeah, so you're
And
starting
if
from
it,
the right side and then you are
yeah,
incrementing the size of that right side also one by one. Yeah,
yeah,
okay. Mm-hmm.
and
Do
since
you
go ahead.
also check the do you when you do that, when you do prefix or suffix, do you consider the empty string you know as the first character of the prefix,
No, no,
and you
I'll
check
take
for
this
empty string?
empty string. I'm not considering, right? I'm picking the first character.
Okay, so you don't consider empty string. Then Then how, when, in what case you treat the empty string?
Okay, so in that case, if you have just s, right, and we have an empty string, so if he's doing the prefix way or the suffix way, when he comes to the end, he says, okay, he picks up s completely. So the other side is like nothing. So,
Empty, you know.
so if you have an empty in the hash set or hash map, then actually that will be a palindrome.
Yeah.
Okay. So the empty string is treated for every for each each word is already a palindrome.
Yeah.
In this case, as a palindrome, but there could be another case, like if it like SS, then we treat it as the candidate for you pair with empty string too, right?
Yeah, yeah. So it will be he's doing it for all, right? The prefix and the suffix.
Yeah,
Yeah.
but then if there's only, yeah, but like, okay, so let's say the input only have like A, B, and empty string.
Mm-hmm.
Okay. So when he go treat for the prefix, he pick A, he look for another A.
Mm-hmm.
So I'll put BA and empty string in my set, right?
Yeah.
So you won't have
Oh,
anything today, right? In this, right? It will be empty.
No, I mean the input is A, not A, B.
Okay. If it is AA, then he
Yeah.
will have a single. He will have two palindromes, right? So he will
hmm.
start from A, from the suffix or prefix side. So A, and then he will A is a palindrome, correct? But then there
Yeah.
is nothing in like the reverse of A inside the hash map, right? So then he will increase its size from A to AA. When there are two A's, so he'll look for the rest of the string which is empty, right?
Yeah.
Okay.
So you have that empty string, right?
And that will form one.
Yeah. Then that means there's no match case for prefix and suffix, right?
Oh, I didn't get that. What
You
do you
I
have
mean?
mean
an
no match case for prefix because for prefix it pick up one A
Uh-huh.
and then he look at the second A. There's no second A, so
Right,
that
right.
there's
Yeah.
no candidate for that.
No candidate for matching. Yeah, you are
Yeah.
right.
So for suffix the same too.
Yeah.
yeah, because
Okay.
A will be both suffix and prefix here
Yeah.
since it's a single
Mm.
character.
So let's say in case of prefix there's no candidate, suffix is no candidate. Now you look for, like you say, you look for AB, any string the reverse of AB, then you, there's no string reverse of AB, right? Because
Yeah.
each of them had to treat them uniquely. Then there are three cases already. Then what
Yeah.
case would you to treat the empty string?
I think we'll have to deal it either
No, but
explicitly, like
say okay. So now you are talking about another example, right? AB and empty. Is it that what you're saying?
No, AA an empty string.
Okay. So A and empty string that will be said, right? So you start with first A from the prefix or suffix side. So what is remaining is another A. So you'll check that another A is present in the hash map. It is not,
Okay.
right? So then you will not consider that option. Then again you will move from single A to double A, right? So then again you are going to consider for, so what is remaining is empty. So you will try to find what if there is an empty in the hash map. If it is not, then you are going to just ignore it, or if it is present, then only you will append it, right?
yeah.
Oh, okay. So in this case, it's empty. We have it.
Yeah, we have that empty. That is what we'll be pushing in the map also, right?
Okay. Yeah.
Or other way, like in try, you put the words in a reverse way. Because if it can be done with dictionary, definitely try will help. Like you can create a node and
Okay.
reverse the word like reverse of it, DCBA, something like that you do. And now you check which word is matching, like D is matching with D, C is matching with C, B and A. So this this forms one, what is it, palindrome pair, right? A
Okay. So
DFS will like
you build a try uh, from the first word in reverse way.
Exactly. Yeah. So one more branch you'll have S, I mean L, and then L. Then you'll have, I mean, you don't need to have S because already it's here only, right? Then L, L, S, S, S. Same thing what we're doing with map, we'll do it here with a try.
Okay. Then after that, you walk through, you iterate through the array, look for then
In
existing one, right?
the,
You, after you build a try, and
then I'll take first word and I'll
yeah.
try to first compare which word is matching the first one. Then
Oh,
I'll go that branch. I'll check whether second word is matching with that or not. Yeah.
nice. But if that's the case, so what was the reason of reverse? Build a try in reverse order. Because if you build a try in the not reverse order, oh, I see. Yeah.
Now then, how will you think that complement of this is present in this string?
Yeah.
To check that.
Yeah.
But okay, so in that case, how you count like 0, 1, and 1, 0? Oh, okay, you do it for every word. Okay.
The word. Yeah. So same process you'll repeat that
Mm.
what you said, what we were doing in the hash map.
Yeah,
Yeah.
that's right. So for in the case of try, as well as
Yeah.
in the case of map, you always reverse the word, right? In the map, you first reverse the word and put in the map,
Yes.
and in try, you reverse everything and put in the try.
Yeah.
Mhm. Okay.
And then repeat the same process what we did in both.
Yeah.
Uh,
And
yeah.
that trick is the main thing, right? You have to reverse it and then put in the map or try.
Exactly. Yeah.
Yeah.
That is
Or
the main.
else, yeah, yeah. That's very simple thing, but it's very important.
Yeah. I mean, it's very tricky to come up to that
Yeah,
level.
yeah, yeah.
Like,
So it was like even I was thinking earlier, like, okay, I'm doing it. Okay, I'm just looking for the first example, and 0, 1, 1, 0 that works. But how to go for this LLS and SSL? Then yeah, if you just imagine it, it's slightly not so easy. So
easy
even
to
if you
come.
put in map or try, then why it is going to happen? How then the reverse one clicks. So then you think about the reverse one. Then what about the previous A B C D and D C B A? And then if you do that reverse also, that will also work. Yeah.
And we have one more shortest palindrome, which is based on same concept only. The follow for this.
Really? Okay.
Yeah.
Mhm.
Yeah,
Okay.
but
That's
it's a
good.
nice approach to retain, right?
Yeah, yeah.
We
It's a very good pattern. Absolutely. Yeah.
have added it in sheet also, like so we
Hmm.
can.
No problem. Yeah.
Yeah, so we can go with the code then.
Sure.
Yeah. Yeah. So this is like just a palindrome function to check. I mean, front and reverse are equal, then it will return true. Otherwise, it will return false. Actually, I'm starting. I mean, the main thing starting from here. So this what I'm creating corresponding. I'm creating a map corresponding to each word. I'm putting its index, word and its index, like ADC, ABCD, and 0, and then so on and so forth. And now this is the final result, like what are the valid palindromes to store. Now I'm going through key as well as the index of that dictionary, whatever I built over here, right? And
Okay.
here the length of each word I'm calculating, because I'll have to go through every letter of the word. And for every word, what you say, I'll walk through each letter of that particular word. So this is the prefix part and this is the suffix part, right?
Mm-hmm.
And I'll pass my prefix part in the palindrome function. It will check whether it's a palindrome, because if it's a palindrome, then only we are going to check the next half, right? Whether the
Yeah.
reverse of that word is present or not. That is the suffix part.
Uh-huh.
So that is what I'm reversing my suffix part, putting it in back and checking if it is not equal to the word and back is not present in my words, then I'm appending it. What you say? word along with its index. I mean the kth I mean the index what we are storing here, because we have to return those two words, right?
Yeah, yeah.
Index. So this part I'm doing over here. Now next is like if j, I mean if j is not equal to n, if I have not completely traversed that word, and this is for the suffix part, and I'll pass my suffix in the palindrome function. It will again return whether it's true or false. If it is true, then I'll take the prefix part and reverse it and again apply the same logic here. If back is not present in the word and back is not present in the dictionary, then you append that particular index and its word. So same thing, this is this is I'm doing for the prefix part, and this is I'm doing for the suffix part. What is it, this part? Same thing
Mm-hmm.
is the repetitive code here, and just appending it to the result.
Okay.
Kind of.
Mm-hmm.
So what would be the runtime complexity for this one?
Yeah, that's a good one. So first we'll create a map, right? So this will be like O of n, right?
Okay.
And then you are going through that dictionary, and for every dictionary you are picking a word and going through each letter of that, right? So let's say the length of each word is k, and the dictionary that I formed is of n, right? Because every word I'll take of that dictionary and then
So in that
go
case,
through
it's going to be O of n, O of nk, right?
nk. Yeah, it will be O of nk. So overall it will be n square only, right?
How come? It
And
might
if
be nk square, not really.
I don't know, let's see.
Is it not nk square in this case?
No, here, like for every dictionary, I mean, this case the length of the word, right, which this for loop is running for,
Okay.
and for every word in the dictionary, I'm going through the each length of the word. So
Hmm.
the length of my dictionary is n, and length of each word is k. So this is for sure order of k into n till this point. I mean, it will cover everything,
But
right?
you have to go through uh, each prefix, right? So how many prefix you have? You have, let's say k, a length of the word is k, then there's k prefix, right?
Yeah.
And you have to check each of them. So
But when you are checking, you are
that
just
be
going in the
k
map,
square.
right?
Map.
For checking, you are just going in the map, so it will be O of 1.
And so number of prefix will be equal to this only, the length of your word, right?
Yeah.
Number of prefix actually is only k again, correct?
K, yeah, that is what, yeah.
Yeah.
So it shouldn't be more than, I mean, if k is equal to n, then it should be n
Yeah.
square. Otherwise,
No, not n square. I think it's only O of n k square, maybe, because you are
But
checking the palindrome also, right?
you need to
oh,
reverse the word too. I mean, the prefix or something, you need to reverse it. Wouldn't that be?
No, we don't have to reverse. Once only we reverse it, right? At the beginning. And we just put in the map.
no, here intermediate will reverse. Like,
Yeah.
I mean, if I check that if this is a
Like,
palindrome,
But that is again k, correct?
yeah, but that is k. It will come under only. Yeah.
Yeah, it is
yeah,
nk square max. Yeah.
that is K, and you look through that so that look through that on line 8, right? And you reverse it on line 14. So
Yeah.
that would be K square. And
Oh, because again I'm reiterating the reversed.
Yeah, but that's not so important, right? Because n k is smaller than n. It's way
Won't
too
be don't
smaller, right? Yeah.
yeah,
Um,
but for the interviewer, we have to, say the
okay, okay. No
preciseness.
problem. But yeah, k or k square or maybe k cube max, right? Yeah. Then it might increase. Okay. But is it really k cube? I think it should not be more than k square, I think.
Mm,
Because see, you are going through the word, right? So
okay.
now word you are actually on line 10, you are going through each and every length of the word. So that will be for, you're going for K. On line 10, it's going to be just K, correct?
Yeah.
J is in the range, whatever, it's only K. Okay.
Length of yes.
Yeah. Then when you go into the K, if you go in the whole of that for loop, you don't find anywhere you are using any for loop, right? It's only the palindrome what you are checking, correct?
Yes. Yeah.
So if
That
you
will
have
take
another palindrome, it's not a nested one. It's all of them are separate, separate. Line 13 is separate than 17. So it will be a single palindrome. So that will be another K. Correct.
yeah.
So
Yeah.
K into K will be K square. And then you have the top line, which is on 8, right? That is N. So it
Yeah.
is going to be N K square, correct?
10K square. Yeah.
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 That makes sense actually.
Or some minor constant can come. I mean, two
Yeah,
past
but
three past.
NK square is the
Dominating
dominating factor, right? Yeah.
should be like that. In
Yeah, I think so. Yeah. It will be, see, someone is asking in the chat how much time it takes to search in the dictionary. So dictionary is of one, right?
yeah, constant.
It's a constant, yeah.
Yeah.
Okay. So I think that is a good approach.
So another one approach is a
Do you have a one for that try?
no, no, I didn't. I
Okay,
just
let
was
me open that.
looking to the discussion. That's it.
Okay, no problem. So I have that one. But I found the try one, what I have done, it's slightly, it's not very time efficient though, but it's good to understand. And then,
Yeah.
yeah, I've just referred it from one of the discussions. So, but I just modified it slightly the way I can templatize it. So this is the try node. I'm using a very simple is boolean and then a vector. Okay, and this is my constructor destructor, and then this is my try class, the very basic template, right? The not the
Yeah.
fancy one. So this is the insert one, just going through each and every word and then going through each and every child. Okay, and then for the search, okay, it's
Yeah.
almost the same what we do, the usual one. And then in the solution, this is for the palindrome the way you did, and then this is the one which starts with. So there are a couple of things I'm doing here. So this is the map. In this map, I reverse the words, what you do the way, and then push that in the map along with the index. Okay, and also insert the reverse word in the try.
Yeah.
Okay, then this is my answer I'll be returning. So then if I, the very first thing I'm doing, I don't know why, but that is what the way it was done there also. So he's looking for if any of the map has a empty one. If it is, then you actually append with each and every one, right?
No.
If it's a palindrome, and that is the first thing what you do. Okay, that's a very different case. And then this is a normal one what you are doing, right? You go through each and every word and go for each and every word size. Okay, then you form the prefix and suffix here is called as left and right. So when you go to the right side, you see it's a palindrome, and then you see the left of that is present in the try. Okay, if it is present and the map of that left is not equal to the current I, okay, then you can actually add that to the answer. Same thing you do for the left side also,
Both the branches.
right? Yeah. So this was for the try. It is exactly the same what we do in the map also, correct, right? Except
Yeah.
for the try search.
This will be more efficient than your hash map, I think.
No, no.
Hmm?
At time wise, it's not, because I don't know, because the way the try was implemented, it's not that efficient. So the map is more efficient, at least the way this was implemented. But it was very easy to understand, therefore I just picked up this solution.
No,
Other
that's
try solutions are slightly different. Yeah, so this was the one.
so yeah, it will be okay.
Yeah, maybe I was trying to avoid this one. I didn't like it, because this should be taken care of the way when we come here, right? Maybe in the try, okay, I don't know, because you can't put any empty one in the try, right? So for
No.
that is the reason he's doing it. I don't know. Yeah, so that was one implementation of the try. And think the one what you described about the map, even I also implemented almost a similar in the C++, and that
Yeah.
gives better results per lead code. But both of
Compared
them get accepted, yeah.
compared to try runtime, which was better.
Yeah, compared to try that the map is better. Because I think in the try you keep searching for each and every string. Yeah, we do that in the map also, right? Yeah. I don't
Yeah.
know. Maybe the one what the empty one, the implementation of empty one is consuming time. I need to work on it, see if I can find a better way of doing it. Yeah.
Mhm. Uh, Bits can be used. I'm just asking if you mask it and check the same mask is present. Hmm.
Yeah, but if you have a duplicate, then what to do, right? So we might have
But
duplicates.
they have mentioned unique, right?
No, bits you'll
Yeah.
be using for a letter, right? Each and every character, correct?
Is it for character?
You'll have to use, right? Is it 26? At least you'll have to have 26 bits.
Bits.
Um, I don't know. So what
Huh.
were you proposing for bits?
No, I thought that let's say first word is ABCD. I mark the bits as whatever. I mean, A is present, B is present. 26. What do you say? This 26 size bit. And
Uh,
then whenever I see the second one DCBA, right? DCBA will also have the same mask, which is like ABCD.
yeah,
So
but that will work, but it won't work for LLS, right?
yeah, there you
You
will
have
have
two LL, yeah. So you'll surely have duplicate characters.
yeah. And when I was seeing KMP, they are using. I'm not sure.
KMP might work, right?
Yeah,
KMP might work than the bit one.
but I didn't get literally like exact pattern we are not finding, right? They're tweaking something KMP, but I'm not sure.
See, KMP for KMP, the way we are reversing and
Hmm.
putting in the try or we are putting in the map, instead of that, we'll have to form a rolling hash. Yeah, we'll still have to put in a map.
Map or try
Yeah,
something.
but then that will be an additional work, I think, right?
Yeah,
So will that not be that? It won't be a very time complexity efficient.
in that case, yeah. Then this is but I mean map and try is better. It will be more complex, I think, using KMP, right? Still, you'll have to use
Hmm.
a map or try along with KMP. Otherwise,
Yeah, you need something supporting, correct?
yeah.
I'm also thinking, Lord, I'm not also not very sure, but yeah. Okay.
Yeah. So we can move to next then, right?
Okay.
Yeah. So our next is like new 21 game. So it's a game in which Alice plays, which is loosely based on the card game. What is it? 21. Alice will start with 0 points and draws the numbers while she has less than k points. Now, during each of the draw, she gains an integer number of points. I mean that those number of points will lie between the range 1 to W, where W will be an integer, and each of the draw will be independent and have equal probabilities. So outcome will be equal in both the cases, right? I mean, picking any one of here, 1 by W minus 1 or 2 by W minus 1, it will be same. And Alice will stop drawing the numbers once he gets k or more points. So what is the probability? She has n or less points. So actually n is 10 and 0 points, and draws the numbers while she has less than k points. Okay. So only one chance she'll get, right? I mean,
Yeah.
she has only 1 point, so it will be 100%. I mean, what do you say?
Yeah. Therefore, the probability is one, right? In that case.
One, yeah. So she has to pick 6 out of 10, right? I mean,
Uh,
they would
not
10.
6. See, the K is 1 in that case, but W is 10. So you'll
Yeah.
surely get the same way. what you do in example 1. But then you'll have to see, compare it with n. What is the probability uh, that Alice has n or less points? That is what it says, right? What is the probability that she has n or less points? So if n is more, in that case, then actually it will be 100%. But in this case, because I think if n is more than w or equal to w, then it will be 100%. But now n is lesser than w. So therefore
Yeah.
it goes to 0.6.
Percent.
So
Okay.
even if you have w more, like 10 possibilities, you still cannot cover all of them. So you can only cover till 6.
Yeah. Regarding some notes,
Yeah.
your will be less than 10,000 and W is less than 10,000.
All are same, but only k and n start from 0.
Zero. Yeah. Otherwise, it's almost.
Yeah.
Yeah.
And so what is the brute force, or maybe whatever is the approach?
Yep.
So what the problem says, like Alice starts with 0 points, right, and she draws numbers while she has less than k points, and every time is she's drawing, she gains an integer number of points randomly from the range 1 to w, right?
Yeah.
So she has to keep pulling till, so what are the values? They are from 1 to w, and then she has to keep pulling till she crosses k, correct?
Yeah.
So if it is k or more than k, then she has to stop, right? So then whatever is the probability, and that we are actually comparing with the probability with n or less points, right?
Yeah. And or less than that. Yeah.
Yeah.
It's lifetime slightly confusing.
And
So
mhm.
this point is bit. So she will draw till the point she doesn't cross K, right?
Yeah, yeah. So she will keep on get taking points from 1 to w every time, and then that will be added, okay, every time. If the k is greater than almost eh, here the examples are k equals 1, right? So and w is 10. So if was k was more than 1, like 5 or so, right? So in that case she will pick up 1, so you'll get w 1 from w, the 2 from w, 3 from w, 4 from w, 5 till 5 she can pick up, right? Or if she's adding, okay, then if you have 1 and then if you have 4, then you'll be crossing 5, so that will be another probability,
So
correct? So
it
you're
will
just
get
picking up 5. Yeah. Mhm.
1 by 10 into 2 by 10, right? I mean, she picked, I mean, had the K been 5, so first time you'll pick, the probability of it will be 1 by 10, right?
If you pick 1 will be 1 by 2 by 1 by 10, correct?
10. And so once we pick that number, will W reduce? No, it won't, right? Because each of the numbers in W is independent and have equal probabilities. Will the probability reduce in that case? For 2? 2 by 9 will it be when she picks 2?
So when she picks 2, and then if your k is 5, right?
Yeah.
So there will be two things happening, right? Um, One is, so you still have 3 to be picked up, right? So then you'll have to find out whatever is the minimum, something like that in that case. Hmm.
Yeah. Archit is mentioning something in chat.
Yeah, Arjit, if you can speak up, I think I'm also thinking loud.
Yeah, that will be better now.
Yeah.
Yeah, I'm able to understand the question. Like, if k is like we need to find the probability for number of like the number of cases. Uh, sorry, like if k is equals to 5 and w equals to 10,
Mm-hmm.
uh, then like if she picks a number which is greater than 4, then she'll be able to draw only once. If it is less than 4, she'll be able to draw like again, like she need to draw again. So I think that's what it's trying to say.
Mm-hmm. Okay. So for each and every pick, so whatever, so that will be one by
Like if she
W, right?
draws one, then she
Mm-hmm.
will have again a choice from 1 to w, whatever she picks. We will add on, we will add that to 1, and then we will see if the number, if the sum is greater than or equal to k, then we'll stop right there. Or if it is still less than k, then she'll have to draw again.
Yeah. So I think the way we can think is if k is say 5, she can get 1 to 10 numbers, right? Any 1 to 10.
Mm-hmm.
So if she gets 1,
Mm-hmm.
then her next, for her next thing, the k will reduce by 1, because now
Yeah.
she already has 1 point,
Mm-hmm.
and n also will reduce by 1, because now
No,
the
10 won't reduce by 1.
So here 10 you are saying N, right?
No,
yeah,
W.
10 is the w.
Yeah. So 10 should also reduce, right? I mean, because
N,
we
yeah,
have.
n should also reduce. Yeah,
yeah,
n
n
should
n
also
should
reduce.
reduce, n and k should reduce with every pick.
Yeah, yeah.
Basically, with if she picks 1, like if you scroll down to the second example, Shashank,
Yeah, sure, sure. Yeah.
second, or maybe
Third.
another one which has k more than 1. Is there one?
No,
Yeah,
we
The
don't
third
have
one.
stone.
that.
Third example. If
Third
you
is
go to
there.
the, yeah, if you go to
Yeah.
third, you have slave 17.
Yeah.
Okay.
So what I'm saying is,
Mhm.
so for one pick we can get one to w, right? First, we can get any of those cases.
Okay.
So if the probability of getting 1 out of 10 is 1 by 10, that is 0.1.
Mm-hmm.
Plus, we have to multiply that. Now, if we get 1, the k reduces by 1. And the n also, for the next iteration, n will reduce by 1. Because now she has one point, and the next time she only needs to pick till she gets 16. And threshold also, n also will be 20. So then we have to solve the same problem for n equal to 20 and k equal to 16.
And W will remain same.
W remains same because she always has that many cards to pick.
Okay. Yeah.
So we can, like, so for the picking 1 out of 10, it is 0.1 multiplied by the result of n equal to 20 and k equal to 16.
And W is
Okay.
10.
And then it
And
keeps on
W same.
decreasing.
Yeah, and plus then same we can continue 2, 2, 2's probability is also 0.1. So then same thing. But in this case, when she picks 2, then k will be 15, n will be 19. I think we can think in that way.
Oh,
So
okay.
first time the probability is 1 by 10, right?
Yeah.
Yeah.
And
Then
yeah,
we have to multiply this by.
multiply this by probability of n equal to 20, k equal to 16.
Okay. I mean, now your N is 20 and K is 16.
Yeah.
And okay, now you'll pick any number, right? Now
Now again for the second number, again it will be 1 by 10 multiplied by n equal to 19, k equal to 15.
okay, yeah. This 19 and this is 15. Okay.
Yeah.
Okay. But in that case,
But point 0.7, how will you
yeah,
generate?
so I think, yeah, that is right. Uh, but is it the probability? Yeah, if it is only number, it also depends on the pick what she's getting, right? So it
Yeah. Yeah.
might be, if it is she's picking one, then 1 by 10. If she's picking two,
2. Yeah,
it
2 by 10.
might be different, correct?
2,
No, but
also the probability of getting the second number is also 1 by 10. But the later on the next false change, like still it is it is a number out of 10 picks, right? So the probability of two is
It will
also
come.
1 by 10.
Yeah, that will be true. But then how 0.7 is coming if this is the or else, I don't know. I was going through discussion. I don't know how they
So yeah, in the discussions, one of the one okay,
he was using this. I mean, he has defined the function like this.
but
So
that is
this is
also
correct.
almost the same what Raj is saying, correct?
Raj was telling, yeah, 1 by 10 that is always fixed, whichever number you pick. And he's in oh, if n is more than 21, that's what he's trying to do. F of n plus 1 by w plus f of n plus 2. So if n was 21, then f of 22 is forming some recurrence relation.
Because you are actually multiplying by that function, right? The function value can be anything. We don't know what that function is, right? Fn.
Yeah.
So that is
A
what.
function f of n is defined as the probability of points between k and n.
Okay.
But,
Okay, maybe Raj, actually, if you have some example what you are following or you want to share, that will be more relevant because, right? So the way he was explaining.
Yeah, I mean, that's the approach I took.
Okay, can you
But
actually just
I
share
mean,
the screen?
yeah, one sec.
Sure. Because there are many approaches, right? So the way Shashank showed up,
Yeah,
yeah.
yeah. One second, let me find it.
Yeah.
This guy. But I'm getting TLE, so mine is not like optimized for runtime.
uh-huh.
But that's how like I logically I try to
At
basically
least your
solve.
example 3 might be working, right?
Yeah, example 3. Yeah, that is.
No, so let's go through your at least approach.
Yeah. Example 3 was working. Yeah.
Okay.
So this is what I was saying. When we draw one, these are possible outcomes.
Yeah,
So 1
I am
to
not
10.
able to see your screen.
Screen is loading only. Yeah.
Really? Okay. Let me
They
stop
say
and share.
double click to enter full screen mode.
Let me share again. Stop and share again.
Do I have to do it? Yeah, okay. That's
Okay.
clear.
So yeah, so for if we take a slightly simpler case, n equal to 6, k equal to 2, and you draw one, we can have these many options, right? So basically, this is how I try to go case by case. So
Okay.
if you read this,
Okay,
and
one draw, you'll draw from 1 to 10.
yeah,
And then for the next draw, you will remove one from that, right?
yeah. So if she gets,
So your
yeah,
W will reduce in that case. So it will be 9. So for the
uh,
first draw, your W will be 1 by 10. Or
uh, W remains the same. The number of cards we can draw remains the same.
No,
okay.
but probability will change when you'll remove the number, right? Since you
Yes.
removed one, it should be in place of 10 in denominator, 9 should come, right?
For the second draw, you mean?
Yeah, for the second round, because you
Sec
killed out that one number. You, oh,
Oh, I
I'm just,
see. I see.
I'm not sure. I'm just thinking out loud. It's not that
I see. I see. Yeah,
uh,
maybe.
Alice stops if she
Yeah,
gets
because
to.
that is what you are actually also coming to, right, on line 11. So case of
Yeah.
11 plus case of 2.
Yeah.
Yeah, the numerator is changing, not the denominator. So denominator is the complete W, that is fine. So whatever is remaining, so that will be on the numerator side. Okay, I got it.
Yeah.
Uh-huh.
But if numbers are changing, denominator should all probability will change, right? Because you remove that number, and each of them is equally probable. So it will be 2 by 9. Next time 3 comes 3 by 8, it should be. Won't it be?
Okay. I mean, the way I read it in the description,
I
Yeah.
think
they
it's
say,
like replacing every time. So like I pulled out a number one. So
Oh,
like again I have choice like if W is 10, so I like again I have choice like 1 to 10. I can select any one of them.
But then
I don't
why the
think
numerator reduces in that case?
numerator is reducing because like in this case I have only the n favoring the number of situations where it is less than n is 5. So like
Hmm.
as he mentioned, like if he takes like for k equals to 2, like he has 2, 3, 4,
Oh.
5, and 6 in the first case.
Uh-huh.
So 5 by 10 there. And for like has if she takes out 1, so like 1 by 10 into now she'll need to draw another number. So the probable like the favoring numbers are basically again 1, 2, 3, 4, 5.
count is giving. Count of how many probable numbers are.
So
Okay.
1 by 10 into 5 by 10.
Mhm.
Okay.
So,
Because the K also reduces in that case, right? Yeah.
yeah.
Mm. Oh, okay. Huh. Yeah, this is interesting actually. Yeah.
That is what he has shown in line number 19 and 18 and 19.
Mm.
19, 20, sorry. I mean, recursive that equation which he has formed. N is
yeah,
constant, is k and w as it is, and multiplying the probability by 1 by 10.
and this is how I tried to implement it.
Okay.
Yeah.
Uh, the base case was if k is 0, then there's nothing, so it's return 1, and if k is 1, then we can then this will be the answer. And the interesting one is basically you have to in for val we can have pick any one number from 1 to w, and if it is less than the threshold means uh, she's gonna need to pick one more card, then it will be 1 times w into remaining one will be n will be reduced by val, and k also will be reduced by the value that she picked.
Great.
Mm. Yeah. Therefore, you will get a different value. It won't be a point one. It will be
Yeah,
something else. Yeah. Based on that,
yeah,
actually, you'll go again in the base case. If it is k equals 0, then it is fine. But if it is k is not equal to 0, it's 1, then you will
yeah,
get the fraction,
yeah.
which will be n
And
by w.
and if it is already less than n, then it just 1 by w.
Mm.
It is passing how many test
It
cases?
is
Because you have memoized it, still it's giving clearly, right?
still it was failing for the bigger one, so it passed 96.
Mm.
So about
That's fine.
yeah, yeah. I thought maybe because it is top down, uh, but this number is big. I think
But
Yeah,
this
your
I
this is
friend,
tried
very
to do it. Yeah, this number is big. I tried to. This is doing it so many times. W is also big, so I tried to optimize it, write in a one line. At least this part, I think maybe I can write in one line, and this part can have a for loop because this is the same, right?
Mhm.
So I tried doing it. It didn't work, but maybe that's this part could be optimized.
Mhm. But do you
And
need a
then
recursion actually? You,
yeah, because it's reducing the value till the point it finds less than k, right? Those many number of
yeah,
calls. Yeah. For
Mhm.
iteration also it would have worked. I mean, by iterative way, right?
Mhm.
yeah, iterative also might have worked. Yeah, or yeah,
Yeah, but if you do a recursive way, at least it's very easy to come up with, right?
Yeah.
yeah, it was easier to understand at least little bit.
Understand
Yeah,
also, yeah. So you just take first one by W, so because you're pulling any one card, right? And
yeah,
whatever is
yeah,
remaining, you just put in the iteration again,
yeah, yeah,
right? So you'll get it. Yeah. The only thing is like your base case. That's very important. Hmm.
yeah, yeah.
I think you're very close. Yeah, you might get it.
Yeah,
You share it once it's done in the Discord.
yeah, I can share this version. I can share.
Yeah, this also you can share and once fully
Yeah,
done. Okay.
yeah.
Yeah.
Yeah, no problem. Yeah, thank you.
Okay, thanks.
Thank you. Yeah. Yeah, you want to share, Prashant, the
No,
one
I
what
have.
you were discussing?
Okay, that one. Okay.
Uh-huh.
I didn't get much. It's yeah. So this is they are using what you say. Mm,
Okay, you are also using a recursion here, right?
recursion only.
Okay.
Bottom up is using. But why is subtracting? I don't know.
Okay, can you hold on the one what, yeah, this one, right? So this is the
Yeah.
one what you were describing. So it is also on the same principle what Raj was showing, to some extent different. If n is less than k, you have a base case of 0, n is less than n, because your n is the input, and that will be, what will be your n? Is it
N is
the k fix?
current
I
point.
think it,
Small n is your current point.
so
Currently, how much
that
points
should
have
be the pix, right? So 1 to w. So
Yeah.
that what you're doing for k, right?
Mm. Yeah.
Okay. So if that is greater than n, okay, it will return 0, because you will never be able to reach that, right?
Mm.
Or yeah, n will be more smaller. Hmm. And if k is less than or equal to n, it is 1, because you will at least be able to reach k. And if it is
Would
n plus 1 less than k,
be subtracting y.
yeah, then in that case 1 plus w and 1 by w, you have two factors. One will be for n plus 1 and other will be for n plus w plus 1.
Yeah.
I didn't understand that. Yeah.
Yeah. That I mean, it's totally like at least Raj's method we are following.
Yeah,
I
it was
mean, it
slightly clean. Yeah. But this might be also good, but I'm not able to understand.
something
I
from
really didn't go in this problem at all.
here. From
I
here
thought
is
maybe I'll
definitely
do
that
later. Yeah.
question.
Okay. Okay. That's
It's
good.
up. We will see. Okay, let's see this one later.
Yeah. Maybe if
Uh,
we get something more, let's share in the Discord. But let's
yeah.
close this problem. I think the probabilities are coming up many times now,
Yeah.
and you might get something like this. So you'll have to work on all of them now.
Yeah. I've included it in sheet. Will.
Yeah, let's include this. Yeah, that's good. It's becoming important nowadays, it seems.
Yeah. A lot of.
So we have a sheet, Santosh.
Yeah.
Uh,
This one.
Yeah, the one what we were.
Roger.
You are also there, right, Raj? In that.
oh,
Yeah. You
maybe I don't have access. Oh, this sheet. Okay, okay,
Yeah,
gotcha.
yeah.
Yeah, yeah.
Just add this, because this topic is slightly interesting, right? And let's get it done now. I think
added.
there were a couple of problems which we are not able to get through. So this is also similar to that, the probability problems, correct?
Yeah,
Yeah.
yeah. Oh, yeah, okay, got it.
Yeah,
Yeah.
yeah. Let's keep that.
Like how will we solve these probability problem? Like do we first go through the like mathematics problems, like simple problem, like when we need the multiplication, when we need addition, or we will
Yeah, I think so. We'll do that way. Yeah. Let's do the basics also in that case, right?
Yeah. From beginning.
Yeah, and then we take some complex as well as the medium ones, simpler ones also. Because this is not a just a probability problem, right? It's something more. So we'll have to
Yeah.
understand all the additions.
Can be greedy. I'm not sure. Like no, it's not greedy. Yeah. So our next problem is like binary tilt. We are given the root of a binary tree and we have to return the sum of every tree node's tilt. And this the definition of tilt is like it's an absolute difference between all the left subtree nodes values and all the right subtrees node values. And if a node does not have a left child, then sum of it is treated as zero. I mean, which is obvious. And the rule is similar if there are no nodes on the right child. Yeah.
Mm. Okay. So this is a tree problem.
Yeah.
Okay. And then how do you think? Do you have a brute force for it? Yeah, maybe
Mm,
not because it's a tree. You'll at least have to go through some of the traversal, right? The
brute
pre-order,
force is
post-order,
recursion only.
yeah, recursion. So either you
Mhm.
do it the iterative way or recursive, but recursive is easier,
Yeah.
correct?
Yeah.
Okay. So what does it say in the so when you want to find a tilt, like yeah, let's go through this example.
Yeah.
So if we are at node 2, he says it will be 0. And
No
why is
right
the
children
tilt
left.
0 in that case?
No left and right children. So zero on the left and zero on the right. So zero
Okay.
minus zero is zero.
So tilt
Coming
of node 2 will be 0.
zero. Three will also be zero because no
Okay.
left and right. And tilt of one will be your two minus three. I mean absolute value of it. So that is one. So sum of these three, zero plus one is one.
Okay.
Yeah. So it's almost like this, what do you say? Post order. I mean, you start from the leaf, right?
Mm-hmm.
Process that part and then keep on jumping. I mean, process all because you need to have value for the top value, right? So from bottom, you keep on processing and
Mm-hmm.
pass that result to the top.
Okay. But if you go to
And
example 2, so
oh,
so okay, in this case, if we yeah, let's take another example. So if you look at this
sorry.
example 2, right? Yeah.
Yeah.
Sorry. Yeah. So if 3 will be 0, that's correct. 5 also is going to be 0, and 2 is going to be, oh, 7 is also going to be 0. But
Mm.
then when you come to 2, it is going to be 3 minus 5, which is
Yeah, for
2.
two. Yeah, that's correct.
And for 9, it's going to be 0 minus 7 because we have only
Seven.
7 on one side. And
Yeah.
we just take the absolute values. But then when we come to 4, so when we come to 4, actually it should be,
Six. I mean, 10 on right, left, 3, 2 plus 5, 10, and 9 plus 7 is 16. So 16 minus 10 is 6.
hmm. So in that case, he is actually adding all the node values till that
Yeah.
for that subtree, correct?
Yeah. That is what like they said. I mean, all the subtrees of all the left subtree node values.
And then we just find the difference over there for
Yeah.
that particular node. Okay. And therefore, you suggest let's go the DFS, sorry, the pre-order way, right? Post-order way.
From bottom to top roots.
Okay. And why you suggest post-order? Because you get all the value information of the left and right subtrees, and that is what you need.
I think any order will work, right? Because we don't need that value for the upper one, right?
Uh, no, we need the left and right all these values, right?
Yeah,
Left subtrees and right subtrees values need them because if you look at the example 2, and then when we are looking for node 4, in that case we are adding all the values of the node on the left subtree and then subtracting them from the right subtree.
I thought difference we are not using. I mean, the nodes values we are using, but difference we are not using any what do you say any advantage of it. It's like I calculated difference for this, the difference for five, and somehow I use this difference to calculate the difference for two. That
Oh
we are
no,
not
so the difference is just being added always to our
doing.
result.
Yeah,
Yeah,
irremovable variance.
yeah. But when we want to pass the value, we'll have to add all the node values and then pass that to the uh, either of the tree, wherever the node comes from, right? Yeah.
That means,
Yeah, so that is good in post order only because you have the values of the left subtree, right subtree, as well as the current node,
correct.
right?
Yeah.
So you can add then and you push that to the next level, right? So in the meantime, you can calculate the tilt for this one, tilt at
Just
this level also. You just subtract the, okay,
yeah.
you got a point, right? Yeah, okay, makes sense. So exactly the way they are describing in the solution
Yeah.
also of the problem, okay.
We can't make use of this difference, calculated difference, to calculate the difference of root. It's not possible, right? I'm just
So we
thinking of.
use that. We use the difference of the two nodes, and that we actually put that in the result. So that is what he's doing. An example everywhere when he says tilt of node 3 is 0, 5, 7 is 0. But if you go for the other nodes, whatever the value you have, he keeps on adding that to your answer. Right?
Yeah, no, but I'm saying if I have to calculate tilt of these two,
Uh-huh.
I can't make like I have already tilt of 3 and tilt of 5. Using those tilt, I can't get the tilt of 2, right? I have to actually subtract those nodes.
Oh no, so tilt for a particular node is just subtracting them, that's all. But
Yeah,
when you want to find the tilt of any node, you'll have to take their node values actually, right?
yeah, actual subtraction.
Yeah,
Yeah,
so
that
that
is
you'll have, because if you take the just subtraction, then it is just something tilt of the previous level value, and that is
hmm,
not we want. We want the tilt of the current node. So for the
yeah,
current node, you'll have to go actually. The brute force would be to go to a node and calculate all the subtree values first and come back, okay, from both sides, and then those two values actually you subtract, you will get a tilt. But to
and
get that value, you'll have to go through the whole subtree, right?
yeah, exactly.
Yeah, yeah, not a brute force. That is the way it is done, right? Yeah,
I said, yeah, yeah.
yeah. I'm sorry. Yeah,
And so here, just DFS function I'm calling. You can say post order, and I'm keeping one global variable which will store all your differences. And we pass it in a DFS function. If there is no root, you return 0. Go to its left, right, and to tilt, you just add the absolute value of left minus right. And at
yeah,
last, we are returning this.
yeah. So in the line 17, the way you are adding the root value plus left and right.
Yeah,
Okay, so the left and right you get it from your subtree at the lower levels, right?
yeah,
So when you add that value, and then you are returning back to your DFS, right? So that the whole value will be the value of all the current subtree, which is rooted at the root, right?
for the next level, it
For
will
the
be
next
this.
level, yeah, correct, yeah. So that is the way you are building. But in the current node, current level, you just go on line 16 and take the absolute value of left and right. So that is the
Left.
only one what you require is required for this level. But
Yeah,
you need this on line 17 whatever you do for the next level.
to go. Yeah,
Yeah, yeah.
yeah,
So that is because we need the left subtree and right subtrees values, and that is the reason we have to do all this thing.
yeah. That's true.
So that becomes important, and that's the reason DF pre-order is better. Then I don't think the other orders might. Yeah, maybe they might also work. You'll have to have an additional parameters in the here in the parameter, or maybe some global variables. No, I think a parameter on line 11, function signature, that also might work, right?
In
You can
that case,
keep on storing the left and right subtree values. Yeah, in the pre-order also you can do that. Yeah, that might be
we'll have
possible.
to tweak a little bit. Yeah.
Yeah.
And level order, no, I don't think so.
No, level order, I think it will be, it might be possible, but then you'll have to maintain a tuple or something like that for each and every node, correct?
Yeah,
You'll have to keep on adding the values. Um, Not
I
necessary.
unnecessary work it will.
Yeah, it might be possible, but yeah, you'll have some more things to do. I never thought about it, the level order way. But the post order should work very cleanly, or if
Yeah,
not, if you want to do pre-order, that also should be fine, correct?
yeah.
Mm.
So just a question. So like, what do you think? Pre-order will work without global variable, or we need global variable for pre-order traversals also and in order also?
Well, I don't know about pre-order. Actually, if you have two parameters in your the function, what he's saying on level 7, line 7, the DFS root, so you'll have another variable like in left and right. Okay, So you'll keep adding all the values of your previous subtrees, right? Left and right subtrees. So when you come in this function, and then when you see if it's not root, and then after that you actually do some, you'll actually calculate the tilt for this current, so you'll have the values of left and right subtree, right? And then when you're going in the pre-order, you'll have to update the left and right by adding the value of the root val every time. So I was just thinking on that lines. I didn't try it, but I'm just thinking loud.
Can you explain it on whiteboard, like what you are trying to convey properly? I did not understand whole scenario, but
Uh, this
Well,
post order.
okay. No, he's saying about, oh, you want to about post order?
no,
No, no,
like
it's
Pre-order, what I was saying is in the DFS route on the line 11 itself, you can have two parameters, right? So if you do it there,
okay, got it.
so
Okay,
here
okay,
itself,
got
right?
it, got it, got it.
Yeah, if you have this left and right, something like that, and then you keep on adding these values when you come here also after this function here, you'll have to do, right? You'll have to calculate the tilt over here, and then when you are doing for the left subtree, you will, instead of these values which are here, actually they will go inside the parameter. That is what I was thinking. So you won't do any processing here, okay, and here also. It's just one way of doing it. Yeah,
yeah. Overall, it's open. Single time you're visiting nodes.
it should be, yeah, because we are
Yeah.
just visiting every node, and we are visiting each node only once, correct?
Yeah.
Okay,
Yeah.
no problem. So